Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Students, today we will continue our lecture this semester with the subject of discrete mathematics, and we start with first topics is logic. Okay. The textbook that we use this semester is Discrete Mathematics and its Application, 7th edition that I have. Actually, there is a 8th edition. You can find online in PDF file. You can just search in the internet. Okay. The objective of discrete mathematics that we will learn is we can mathematical reasoning, or in bahasa berpikir secara logis matematis. And the second is we can make a combinatorial analysis. This is kemampuan menghitung. And then we can make a discrete structure. We can, number 4 is algorithmic thinking, and we can make an application and modeling. Okay, this is actually the discrete mathematics is the special mathematics for computer scientists. It is different with the continuum mathematics. It's like calculus or linear algebra, like this. Quite different. We will explain in detail after this. Okay, we will start with the foundations in discrete mathematics, logic and proof, and in this occasion we will start with logic. Okay, we start with the proposition. Proposition, the definition, is a declarative sentence that have the value either true or false, and we have emphasized but not both, only one value, true or false, and this is in bahasa. So proposisi adalah pernyataan benar atau salah. We cannot have both, jadi hanya boleh salah satu. Example, the proposition is Washington DC is the capital of United States of America. This is the sentence that have value, and here is true. Toronto, the capital of Canada, is sentence that have value but false. And 1 plus 1 equal to 2 is true. 2 plus 2 equal to 3 is also proposition but false. This 4 sentence is propositions because the sentence has value either true or false. The example of a proposition that cannot be judged as a proposition is like the example 2. The number 1 is, this is a question, not the proposition. The number 2 is command or order, not a proposition. The number 3 also not a proposition because we cannot judge true or false, depend on the value of x. And number 4 also not a proposition because we cannot judge true or false, depend on the value of x and y and z themselves. So the proposition is the statement, sentence, declarative sentence that have value true, either true or false. Otherwise, it's not a proposition. Okay. in the discrete mathematics, we use the small letter, and the value we use true or false, G or F. Okay. Definition 1. Let P the proposition. The negation P denoted, I make bigger. It is just like minus, but like little bit down like this. P, like this. I repeat it. Minus, small letter P. I will like this. Okay. Also, we can denote it as P with head. And in English, minus P or not P, we can read as not P like this. In the statement, if P is a proposition and not P is, it is not the case that P. It's not the case that P. For example, if P is Michael's PC runs Linux, and not P is Michael's PC does not run Linux. I should emphasize that the negation is not in the subject but on the predicate. So the Michael, the subject, always as it is, Michael's, but that have value of negation is only on the predicate. So if the positive statement is runs and the negative is does not run. In bahasa, maybe we can explain. Max PC runs Linux, PC-nya Mac menggunakan Linux. Dan kalau the negation of P is PC-nya Mac same tidak menggunakan Linux. So the value of negative is imposed on the predicate, not on the subject. Okay. Then the table 1. If P is true, then not P is false. If P is false, then not P is true. It's very logic. Okay. Definition 2. We will explain about the conjunction. Conjunction is the operation that we use like this. In a statement, we can read as N. P and Q. This is N. This is the conjunction operation. If P true and Q is true, then P and Q is true, just like operation of N. So only if both is true, then the value of conjunction is true, otherwise is false, like this. For example, students that has passed exam of calculus and linear algebra. Okay, I will read it in English. The students that has passed calculus and linear algebra can get the subject of discrete mathematics. So this is must true. So this is can be true. Otherwise is not true or false. Okay. And the second operation is disjunction or atau. This the false value only happen if both proposition is false, otherwise it's true. Okay. For example, students that has passed calculus or algebra linear can check discrete mathematics. So if there is only one true, is true, and if push true also has the value of true. Okay, and then the next is the exclusive OR. Exclusive OR is only true if only one of the statement is true. If both true is false, or if both false also false. This is in logic we can explain. If the student has passed calculus, exclusive or linear algebra, can check discrete. If student has passed both of them, he must check another sophisticated subject, like this. The logic is like this. Okay. Next is the conditional statement if then. This is if then statement. If then. If P then Q proposition. For example, in here, if P true, Q true, then P, if P then Q is true. Logically, if I pass discrete math, I will treat you. Yeah. So if I pass and I treat you, so this is true as expected. And if this is true and this is false, so the if Q then Q is false. Okay, because I don't treat you is wrong. Alright, but if I fail in mathematics discrete and I treat you, it's okay. If I treat you, this is my kindness. And if I fail and I don't treat you, then also true, because as expected also. Okay, like this. Next. Okay, the big conditional statement is write down like this. The arrow with both sides of eye of arrow. Okay. If and only if in English, or jika dan hanya jika in bahasa. You can drive a car if and only if you have the driver license that properly. You have a proper driver license. So if you drive car and you have the proper driver license, so if and only if is true. And if you don't drive a car and you don't have a driver license, also true, like this. Otherwise it's false. I think it's easy to understand logically. Okay, the tools, then we'll talk the tools that we can test the value of proposition. We use truth table. Like this is the truth table atau tabel kebenaran in bahasa. Okay, for example, construct the truth table of this value. Okay, we will construct this first. P and Q, we have a 4 probability: true, false, true, and false. And then, as expected, we should construct this first. If Q is true, then not Q is false. This is actually contradiction of this. Okay, and then this is we construct this proposition, and this, and here, and here, and here is construct here. Okay, I think this is easy to understand. And if you have any question, we can have detail in our next synchronous lecture. Okay, we can also have a bit operation. True is 1 and false is 0. Okay, it's very similar. This is the OR, this is AND, and this is exclusive OR. And I think this is the operation. This, and this, like this. Okay. For example, 0, 1 or 1, 0, 1 and 0, 0, 1, so 1, like this, and so on. Okay. We have some definition. The first is tautology. Tautology is compound proposition that always true. Like this. This is tautology. True. Whatever the value of input is true. Otherwise, its contradiction is always false. Whatever the value of input, always false. So this is tautology. This is contradiction. Okay, we have a very famous law, De Morgan's law. This will be frequent limit at the next subject, maybe on the logic or on the coding of computing next level. De Morgan law will frequently being used. Okay, for example, we can solve this problem so that not P or Q and not Q and not Q is logically equivalent. So we can use the truth table. So this is the result of this, and this is the result of this. As you can see, this is same, always same. So we can prove that the compound proposition is correct. Okay, this is also has this similar way. Okay, this is okay, and this same value. Okay, these are some properties that you can prove by using the truth table. For example, here, as is said before, this is same. Yes, same. The tools is the truth table. We can check by ourselves. Okay, and this is the assignment. You can use the truth table. Start with P and Q. True, false, false, true, 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 or false, false, and then you can check. You can arrange the answer of this, and you should prove that this is a tautology. Okay, I hope it's very clear, and we can in detail discussion on the synchronous lecture. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.